Yes, we are live. Okay. Can I get a quick yes or no whether I'm audible or am I good? So hello guys. I guess I hope everything is fine. Okay. So if not, please let me know in the chat session. So with that note, let's get started. Okay. So myself, Vamsi. Okay. I currently an associate software engineer at SNNCS Hyderabad, and we started this particular Python interview preparation course and 15 days ago. Now today we are at lesson number 13. Okay, it means that we have already completed 12 lessons. Okay, so which covers right from the basic. Okay, so L lesson 0 starts from right from the basics of Python. Okay, and the aim of this particular course is to provide a one-stop solution, one-stop solution, like for your next Python interviews, or like it's an interviews. Okay, don't say it's at a Python interviews. Okay, so this entire course is focusing more over for the freshers. Okay, and what I mean as a freshers, so if I say experienced guys, okay, if I say experienced people, and if I say Python interview preparation, then they mean that like they expect development. Okay, but when I say freshers, they expect the concepts. Okay, hey, hi Shraddha. So this is how it works. Okay, like for freshers language doesn't matter. Okay, for experienced people language matters the until like they expect development, right? Like some experience, some kind of experience. So if you are attempting any Python interview, it means that they are expecting you either Django or Flask or any Python automation for testing roles. Okay, so that's why I'm clearly stating that how much Python should I know for interview. Just tell me what is your aim, what is the package that you are aiming for, then I will tell you. Okay, so and okay, just tell me that. Okay, I will tell you what to focus. Tell me the package or company. I can say company, just tell me the company. Okay, I will tell you what to learn in an Python or so okay, so generally companies है ना, companies don't expect one particular programming language. Okay, they don't expect only Python, they don't expect only Java. They expect a people, at least like for freshers. Okay, at least for freshers they expect some good concepts knowledge and a willingness to learn new stuff. Okay, willingness to learn new stuff. Microsoft, Google. So when I say, when you are saying Microsoft, Google, Amazon kind of things, don't focus on like programming language. Okay, so just focus on the concepts like, okay, so DSA, and at least it will be good if you could able to solve at least 300 to 400 problems on lead code. Okay, and some like few, like at least like 150 to 100 CP problems. It's okay, like if you're not even on live contest, just upsolving. Okay, so why CP now, like why CP now, why not only DSA? So basically today's the trend. Okay, so today's the trend is going on more on this kind of companies. Okay, So people are aiming for these kind of more companies. Okay, so that's why for the first round of filtration itself, they made OAs, like online assessments, a little complicated. Okay, little complicated. So yeah, it's same for product based companies. Okay, product based companies जो है ना, like 10 plus LPAs. Okay, so the same चीज होता है, like so they are toughing, like day to day they are becoming, okay, their OS are becoming tough because the number of applications are getting increased day by day. Okay, that's why. So they can't interview like 1,000 people for 3 to 4 roles, right? 3 to 4 openings, they can't interview 1,000 people. That's why they try to eliminate at least 900 people from an OA. Yeah. So then there will be like let's assume they are taking 100 people for interviews. Then at last, after multiple rejection, like multiple rounds of filtration, they will take 3 to 4 guys, okay, for freshers. That's how it works. But जो off on campus है ना, like for on campuses, it is slightly different scenario, I guess. Okay, like I heard from my some of my friends, okay, who are studying in some tier 1 college. They used to say like, okay, the interviews were not that much tough. Either these OAs are not that much tough as an offline OAs. Okay, like yeah, competition जो है ना, like so if you go to IITs, everyone is that much equally knowledgeable, equally talented, so competition will be tough there as well. Okay, so you need to prepare, that's it. Okay, so this CP problems will help you to solve like to clear OA rounds. Okay, so nowadays OA is like Hacker Earth, okay, Hacker Earth or Hacker Rank, or like two major OAS platforms. Nowadays every company is focusing more on, so yeah, try to solve from this kind of thing. I am from tier 1 college. Then you might know the situation, right? Like since you are from metallurgy department, I don't know, just go and ask your CSC friends or EC friends. Okay, they will tell you the better scenario. Okay, like just talk to them for 10 to 15 minutes. Okay, 10 to 15 minutes, then you will get to know how they are preparing for that such kind of companies. So learning Django or Flask along with Python is the best. Yes, for development. Yeah, for development, like it's not like do only development, do only DSA. So have some, like if you are from fresher, like if you are still in college, try to have some things. Okay, like so at least 2 to 3 projects. Doesn't matter whether it's a be it web, be it Android, be it machine learning, doesn't matter. Just have 2 to 3 projects, okay, with some good experience. Okay, like try to involve as much as you can, or be it group projects, be it individual projects, try to involve more. And just remember whatever happened, be it like any challenge that you are faced. Okay, because in an interview they don't care about your project much, but they only care about how you are able to tackle your problems while solving real world problems. Okay, how you are able to communicate with your team members, it's if it's an group project kind of stuff. Okay, so that is important. Okay, like I can say simply take any clone projects, like YouTube clone, okay, Swiggy clone, WhatsApp. Okay, like do any clone, like there will be plenty of tutorials available on YouTube. Okay, so do any projects, but don't name it as a YouTube clone. Okay, since you have made everything on your own, just try to name it as something different. Okay, on your own, that will make sense. First development from HTML or Django. HTML, basically in Django as well, like Django mostly used for REST APIs development and backend stuff, I guess. Okay, front end not sure Django में front end कैसे करते हैं. Yeah, so for anything for web development, first start with HTML and CSS. It's recommendable. Okay, so if you are using Flask or any other things as well in Django, I guess, yeah, you need to use your HTML there itself, at least some basic stuff. Okay, good. So yeah, we have spent 10 minutes. Okay, so let's come to the topic. Okay, so yesterday we started recursion. Yesterday we started recursion, so it is going to be recursion 2. Okay, recursion class 2. Okay, recursion class 2. Recursion class 2. Now if you remember, yesterday we have solved a factorial, Fibonacci, and a sum of natural numbers. Yes, and I asked you guys to try a few other problems. I guess yeah, these are all. So let me know whether you have solved at least two of them. Okay, and do you got a chance to explore what is head recursion and tile recursion? Do you got a chance to explore what is head recursion and tile recursion? Yes or no? Okay, so I will give you a glance about what does it mean. Okay, so yeah, we like it's very simple. Okay, like let's say we can simply say head means front or a top, a tile means back. Head means a front and a tile means back. And what does it mean? So you are like you are doing some task, right? Like if you say um, okay, let's take one problem. Okay, so I will be giving you a n. Okay, I will be giving you a n is equal to 10 or something like that. Now you need to print all the numbers, okay, in a reverse manner, starting from 10 to 1 using recursion. Okay, using recursion. Now how can you do that? How can you do that? How can you do that? All code in written. All code in written. Okay. Yeah, you are right, but it's not the way you can explain it. Okay, so just try to solve this problem, you will get it. Okay, so let's say we have a function called of print num, and I will be giving you a 10. Okay, I will be giving you a 10. Now at first what I need to do, so I will be currently at 10. So at first I need 10, right? First I need 10. Then what is the first work that I can do? Okay, so can I say I need to print 10? Print 10. And then what I need to do? Then what I need to do? I need to say print 9. Print n of print n of n minus 1. No, that's not the way you can. Now I am currently at 9. Now what I can do? I can say print 9 at first. Okay, then I will go and say print num 8. So what is the first work that I am doing? So like if I wanted to convert this same thing into my code, what I can do? So let me first tell me what is the base case. When do we need to stop? Base case, when do we need to stop? Can I say we need to stop when our n is equal to 1? Whenever we have reached our n is equal to 1, we need to stop there. Agrees? Because that is what, wherever it doesn't matter wherever I am starting, it only matters I need to stop at 1. So I can say that if n equal to 1, like sorry, when n is equal to 1 as well, I need to do the task. Whenever n is equal to 0, I need to stop. Okay, so I will say simply return, that's it. Okay, now for all other cases, what is the first work that we are doing? We are doing, for every number we are printing the n, then we are going to the next number, that is n minus 1. Just assume you have a function called print now. Agrees everyone? This is what we are doing, right? Right? Agrees? Now let's go and try to code this particular approach. Okay, then we'll discuss what is head and tail. We'll come to that part later. Okay, you will be telling what is happening over there. Okay, so first let's go and try to code this up. Okay, so the def print a num, and it will be taking n. Okay, so whenever my n becomes 0, I will just say return normally, and if not, I will say n print n, then print a num of n minus 1. Yep. So I will call a print num, and I will set 5. Okay, I will say 5. So if I run this code, what I got? I got 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. Yes. So are you clear? Are you clear what is happening here? Are you clear what is happening here? Are you clear what is, like, if you want, I can draw the this stack 3. Okay, stack, like how this particular thing is working. So let's consider we have a stack like this. Okay, and we have a console where we will be printing our output. Okay, where we will be printing our output. Now at first, what is we are calling? We are calling a print 5. Yes, we are calling print 5. Okay, it will go here. Okay, it will go here, and it will check whether n is equal to 0. No, it's not. Now it will come here, and what is the first statement it is doing? It is printing n. What is the n now? Can I say it's a 5? So I will get a 5 in my output. Done. Done. Now what is the next line? The next line is print num of n minus 1. So again it is making a call. Okay, it is making a call for 4. Done. Now again it will repeat the same task. So it is not equal to 0. So print n. So when I say print n, it is going to be 4. Now what is the next task? It is going to do the print num n minus 1. So when I say print num n minus 1, it is going to make another call, print 3. Okay. Now again I will do the same task, and I will repeat the n minus 1. Okay, pn of 2. Now again I will do the same task. Okay. So again n is equal to not equal to 0. So print that, and go for pn of a 0. Now tell me what will happen. Now tell me. So now my n is equal to 0. My n is equal to 0. What does it mean? So I will simply return. Okay, it means that I am done with this particular call. Okay, I will remove that print num of 0 from the stack. Okay, now I will come back to the here, this line. So wherever I am calling, I will come back to that statement back. Now I will go to the next line. Okay, is there anything to execute after that particular statement? After this print num of n minus 1, is there any particular statement to execute again? No, there is nothing, right? So I will go to the next call. Okay, whoever call that particular call. Okay, so it's a pn of 1. So I am done with pn of 1. Okay, I will done with pn of 1. So there is nothing after calling back. Okay, so it means that I will come back. So again I'm done with this. So it is like you will have a function call here. So above you will have some work, below you will have some work, right? So before coming to this particular function call, you will do all of this task. Okay, you will complete before calling your function. And what about the remaining work that is happening right after the function call? You need to do the you need to go to the function call. First you need to complete that guy, then come back, then solve this guy. That is how it works, right? Now again there is nothing for pn of 3. Again done. So we will come back after 5. We will come back to here. Okay, so we have 5 4 3 2 1 in the output board. This is how it works. This is how it works, right? Understood? Okay, now I will tell you the another scenario now. Okay, I will tell you the another scenario. Okay, I will tell you the another scenario. So I will just remove this, all of this, and there are some code changes required. Okay, now I won't do anything. Okay, I won't do anything. I will just remove this statement here, and I will put this statement back here. Okay, now I will execute it. Okay, what I got the numbers again, but this time starting with the 1 and till the end. Do you want me to explain how this is happening? Again a call stack. Do you want me to do? Okay, I will do that. Okay, it's not a big issue. Yeah. So let's say you have a stack. Okay, and at first I'm making a call to pn of 5. Okay, and this is my console. Okay, this is my console. Now I will enter n is not equal to 0. So I will come to 4th line. Now from the 4th line it is calling again. Okay, so it is calling pn of 4. Okay, pn of 4. Done. So until now I haven't print. Okay, from here directly I'm again going back to the top itself, right? Now again I will repeat the same. So I will get a pn of 3 again. So here, then again I will get a pn of 2. Again I will get a pn of 1. Again I will get a pn of 0 this time. So whenever it is becoming 0, I won't do any task. Okay, I will just return from here. Okay, I will just return from here. So I will just return from here to this particular statement. So it means that I came back to here. Now after I have completed this task, right? Now what is the work? I need to go to the next line, which is a 5. Okay, what is happening in 5? So print n. What is the n now? What is the n now? Can I say it's a 1? Can I say it's a 1? So I will get a 1 here. Now is there anything after that 5th line? No. So I'm done with this particular call. So I will go to the pn of 2. So I will come back to this line, and I am done with this line. So I will go here. So I will print a 2. So this time 2 is 3. Sorry, I will print my n. So n is 2. Okay, so this is how it happens. Okay, next 3, next 4, next 5. So this is what happens. Okay, and this particular recursion is called as an head recursion, where we are making recursive calls before doing any task. Okay, before doing any work. Okay, like it will be something like this: function call and some work. Okay, so when your recursion is in this form, we can call it as a head recursion. And if your recursion is something in this form, like where after your function call you are not doing any work, then that is called as a tail recursion. Done? Understood what is the difference as well? Okay, just let me know still if you have doubt. Okay, Now let's go and solve another interesting problem with using the recursion. Yes. Yeah. So let's solve palindrome using recursion. Palindrome using recursion. Okay, so you guys know what is palindrome because we have solved this problem using loops, right? So now how to solve this using recursion? Okay, how to solve this problem using recursion? How? So one thing that we need to make sure is we need to check whether we have a relativeness or not. Yes, we have a relativeness or not. So just confirm me whether we have relativeness for indexes of a palindrome or not. Okay, then yeah, then we need to figure out the base case, means when do we need to stop. Okay, so I'm not interested in the all the discussions that we made during the loops, but I have discussed one solution which uses two pointers. Do you remember that? Two pointers. Like if I say a madam, I have used two pointers, like where I will be pointing one to here and one to here, and I will be doing just checking these things. Yes, did I discuss this something like that? Okay, so every time if this is equal, then we are moving one by each. Yes, right, we have solved this. Yes. Now just think this solution, how can we solve this? Okay, so for this what will be your recursive call requirements, like what is your function expects? So your function expects a string, yes, a string, and two indices, let's say p1 and p2. Okay, p1 and p2, right? So p1 will be a 0 for sure, and p2 will be n minus 1, where your n is the length of minus 1. Okay, length of the string. Okay, so we have a function. Okay, now we need to figure out the base case. What is the base case? While, like I have told you when to stop that while loop. Okay, can you tell me that way, when do we need to stop the while loop? And so the work that we need to do here, we need to increment p1 plus like p1 equal to 1, and we need to decrement p1 minus 1 when both the p1 double equal to p2. Okay, so in all other cases we can simply return the else, like false, sorry, we can simply return false. Yes or no? Do you remember when to stop that? Do you? Yes. So if you remember, I've told something like p1 less than or equal to p2. p1 less than or equal to p2. Yes or no? So it means that so we need to repeatedly check whether our both the indexes are equal. So if it is equal, we can just do this thing. So if that is not equal, then we can simply return a false. That's it, right? Simply return a false. So how can we write code for this particular thing? So can I say like a function and like a string p1 and p2, and I will first check if p1 less than or equal to p2. So if this is the case, okay, if this is the case, if this is the case, like, oh sorry, you can say whenever your p1 crossed p2, okay, p1 crossed p2, then you can say true return true, right? So like here we have crossed, whenever we have crossed, like we are pointing p1 here and p2 here, it means that till now we haven't every indexes are equal, okay, every indexes are equal, so that's why we came till here, okay. So if this is not the case, we need to check if string of p1 double equal to string of p2. So if this is the case, if both are equal, what we need to do, we need to simply return a return like function. Again we need to call back, right? So p1 plus 1 and p2 minus 1, the same task we need to repeat, right? And I will return, okay, I will return true if everything goes well, and if not, at the end I will return a false. Done. So got it, or do you want me to explain it better way? Okay, let's take madam only. So at currently our p1 is 0, p2 is equal to 4, okay. So we'll enter into this particular block, okay, we'll check them. So both m and m are equal, so we'll enter into this particular block and we'll return function of s p1 plus 1 minus p1 p2 minus 1, okay. So I will now, it will become 1 and 3, okay. So a and a, so I will come back, okay. So this is not the case, now it will again enter this, and yeah, a and a are equal, so again I will make here and here. Now again p1 not greater than p2, yes, right, it is equal but not greater, okay. So it will return false, so it will come back here, and we'll check, okay. So now we will increment our points, okay, both d and d equal, so we will increment our points, it will become 2 and 2. So sorry, 2 and 2, okay. So yeah, it's not 2 and 2, sorry. So it is currently pointing 2, so it will become 3 and 1, okay, 3 and 1. So now this is the case, so we'll return true. So for till now every function call returns true, so at the end we'll return true here itself, okay. We don't go to this particular statement because we are just returning here from the function, okay. We don't execute this, that's it, okay. So yeah, okay, let's quickly go and try to code this. So let's say s is equal to okay, and we have a function called palindrome, and it will be taking s p1 and p2, and if p1 greater than p2, will simply return true. If or like I will just check, okay, if that is not the case, I will just check whether both are equal. If both are equal, I will say return, okay, palindrome of s comma p1 plus p2 and p2 plus, sorry, p2 minus 1, okay. So at the end, if this is not the case, okay, I will just return false. Now I will call, okay, so it's not true, yeah, it's true. Here it is going to be false. Now I will call let's say answer is equal to palindrome of s comma 0 comma length of s minus 1, okay. Now I will print my answer here, and like so yeah, so since we are returning either true or false, if we got a output as a true, it means that given string is a palindrome. Otherwise it is an not a palindrome. We can just put a like if condition here and you can check that. Okay, I'm not doing that here. So we got it true here, it means that it is correct. Okay, so I will give a Vamsi this time. Okay, and yeah, so it is giving me false. And if I give a single character, then it should return it's a palindrome. Yes. Okay, it is working fine. So got it how we can solve our recursion like a palindrome using recursion, and try out for reverse as well. Okay, try out for results. Now let's go and solve another problem. Okay, like yeah, it will be a good problem. It is going to be a very good problem. So do you ever heard of word called subsets? Do you ever heard the word called a subsets? So let's say if I have given you an list of uh, numbers. Okay, if I have given you list of numbers, you need to return all the subsets. Okay, all the subsets of a this particular list. Okay, so a few people even call it as a power set as well. Power set. Okay, so you know the what is subset, right? So subset is the like some part of the list. Okay, some part of the given input. Okay, it might be empty. Okay, it might be any combination of letters, any combination of like elements. Okay, so I will write an subsets of this particular thing. Okay, like so when I say it's an empty is also an subset. So the one way to whether check whether you got the like whether you are on same page or not is, so for a given like if you are given the list or string with the size of n. Okay, like let's say size of n is equal to 3, then you will have a 2 power n subsets. Okay, 2 power n subsets or a power set of an particular n sized list or string. Okay, so for this it is going to be 8 subsets. Okay, so let's see what are all the 8 subsets. So first one is going to be empty, and second one is going to be one sized all, and then it is going to be a combination of twos, and then it is going to be combination of threes. So do we got all these things? 1 2 3 4, yeah, we got 8. Okay, so the thing here is always your here the order. Okay, the order has to be in increasing order only, not like so I can say 3 2 1 is also one of my subset. No, okay, it should always be in a increasing manner. The next. So how can we generate this? How can we generate this using a recursion? So if you have any idea, you can tell me. Okay, otherwise let's dive into the solution. Okay, so it will take some time, I'm pretty much sure for it, because my intention is to not to teach you programming. Okay, like I my intention is to teach problem solving. Okay, so it will take some time. Okay, be patient. Okay, so like within 5 minutes you will get it. Okay, within 5 minutes you will get it for sure. So let's get started. Okay, let's get started. Yeah, so initially you will be standing at the index 0. Okay, you will be standing at the index 0, or it doesn't matter if you wanted to start from the last as well, you can. Okay, so let's start from the last itself, because till now we have seen only starting from last, right? So let's start from the last only. So if you are saying at the last, it means that last index. Okay, when I have given you the 3 as my input, like if it has contained 3 elements in a list, then my index would be 2. Now in the additional to this, I will be requiring an one dummy list. Okay, dummy data structure. Let's assume dummy data structure. Okay, dummy data structure. So where I will be taking all the elements which I'm currently at. Okay, so let's take it as a empty, as of now empty. Okay, because I haven't taken anything yet. Okay, now basically, so whenever I'm at one particular number, let's say if I'm currently at 3, okay, so it's my choice, right? It's my choice whether I can pick up that element, okay, or not. Okay, like at the end anyhow I'm going to generate the subsequence, sorry, subsets, right? So I need an subset which has all the elements. Okay, so it doesn't matter whether all the elements are there in a one particular list at the same time or not, but I just wanted to generate all the. So let's say if I have considered I don't want any element, then I will get this. Okay, if I consider I want all the elements in my answer, then I will get this. Now if I decided to take this particular only 1 and 2, then I will get this answer, right? It's my wish, okay, whether to pick an element or not pick an element. Okay, so just carefully observe. So in this particular problem we are going to solve backtracking. Okay, I am introducing you guys to backtracking. Okay, what is backtracking? Okay, so don't worry if you ever heard about this word. Okay, just stick to me. Okay, now if I'm currently standing at second index, okay, if I'm currently standing at second index, so it means that it is a 3. Okay, just consider it's your wish. Okay, it's your wish whether you can take that element or you cannot take that element. Okay, so we will see the both cases. Okay, we will see the both cases. Okay, let's assume you have taken that element. Okay, here you have taken that element. So if you have taken that element, then you need to put it in your data structure. It will be 3. Yes, agrees. Now you need to go to the next element. Like you are done with one element, right? Okay, then you need to make your n is equal to n minus 1, so it will become 1. Okay, done, understood. Okay, so if you decided not to pick up that element, okay, if you decided not to pick up that element, then okay, then you need to move to the next guy and your list is going to be same, like empty, right? Empty. Now I have again, so this is, I need to string it this particular 3 to the end. Okay, what will be my base case? Let's talk about base case now. What will be my base case? So whenever I reach to n is equal to 0, n is equal to less than 0, okay, I need to consider 0 as well. So whenever I reach to n less than 0, it means that I can't go anywhere. Okay, I can't go anywhere. I need to stop it there itself, because my last index is going to be 0 only. So I will print my ds, like whatever data structure, okay, values I have, I will print all of them. Okay, so now I am currently here, so 1 not less than 0. So now again I have 2 choices. What is that? So I can pick up that, I can't pick up that. Okay, let's assume from the right hand side I will be writing only all the pickups, on left hand side I will be writing all the pickups, and right hand side I will be writing all the non pickups. Okay, so if I pick up that guy, okay, then it is going to be 2 and 3, 2 and 3. Now if I decided not to pick up that guy, it is going to be only 3. Okay, let's try to sync this as well. Okay, so if I decide to pick up this, then it is going to be this, and if I decide to not to pick up that, then it is going to be empty, right? Now let's go and do the same for this key. Okay, let me, yeah, okay. So now again I decided to pick up this 0. Okay, then it should be -1, 1, 2, 3. So if I decide not to pick up that guy, it would be -1, 3 and 2. Okay, so again I have two choices here. If I pick up that -1 and 1 and 3, if I decided to not to pick up -1, alone 3. Okay, for this again I have -1 and 2 and 1, and if I decide not to pick up -1, 2, alone 2, that's it, right? Now again for this I have two choices. So if I decide to pick up that, it is going to be -1 and 1. If I decide not to pick up, it is going to be alone, that's it. Now just check. So in all other all the options that we have now are less than -1. So I can't string the tree because that is the last index. Okay, so now I will go back, go back, go back, go back, that's it. Okay, I need to go back. So whenever I am going back from here, I have to remove this, like whatever I have added here, I need to remove that, because we have seen, right, that head recursion. Okay, so if we will reach here, so from that point we will go to here. Okay, the next statement, we can't do same parallel function at the same time, right? So first we'll do this, and for next we'll do this. Now if we do this in our data structure, we do have 1. Okay, by going to this particular problem, we need to remove that 1. Okay, whatever there in top, okay, we need to remove that, that's it. Okay, so we see, okay, like let's try to write the code. Okay, so here the data structure which I am using is a DQ. Okay, if you don't know what is DQ, it is something like this. Okay, like if you know Q, what is Q? So Q is FIFO manner. Okay, first in last out, like whatever element you put it in a queue for the first time, that will be get out for the first. Okay, but like it's an one-sided like ending. Okay, one side, one way kind of thing. But DQ is a two-way communication kind of stuff. Okay, like you can go out or in both the directions. That's an DQ. Like if you don't know, it's okay, but as of now just remember that we are using the DQ data structure. We'll discuss that DQ, what is DQ, in later part. Okay, so let's assume we have a function called generate subsets. Okay, where we will be giving our n and a given list. Okay, like input list and the output data structure, which is an DQ. Okay, which is an DQ. So basically we are not passing this DQ, so like by default it will be get assigned to the DQ. Okay, so basically what is the base case? If n less than 0, whenever we have seen our n less than 0, and we need to print whatever we have in the output, that's it. Okay, so in other cases, what we need to do? In other cases we need to first append the thing. Okay, we need to append it, like let's say output append. We need to append like whatever index we are currently, like list of n. So append means it will append the element at the end. Now after appending, what you need to do, you need to go and do the same for the next generation, like for the n minus 1, n minus 1 ls and the output. Okay, now after doing this particular task, okay, so you are done with this, you are done with this, you are done with this. Now you need to go to this particular call. You can't directly go here. Okay, you need to go to the top. Okay, whenever you have reached top, you need to come to this particular state. Okay, like where your data structure is only 2 and 3. Okay, so you need to remove the top element. Okay, so you can use the operation called pop here. Okay, which helps you to remove the top element. Okay, then you need to repeat the same task, like generate subsets n minus 1 ls and the output. Done. So on a high level note, this is what we are doing. Okay, I hope you got the point or problem. So if you haven't still understood it, please let me know. Okay, so yeah, try spending some time. Okay, so this is what generally backtracking problem looks like. So what is backtracking problem now? Trying all the possible ways. Okay, and then removing some task. Okay, like it's like a do or die kind of situation. Okay, like you need to go try, okay, then experience and come back. Okay, so here you are putting that, okay, trying that, and after coming back you will be removing that and again trying back. Okay, this is how generally backtracking problems looks like. Okay, so yeah, let's go and try to. So a def generate subsets which will take n ls and output which is an dq. To use dq you need to import the module. Okay, first we can just go there. Okay, so from collection, so dq is available in collections, import a dq. Okay, if you do this statement, you won't get any error. And after that, let's try to write the logic. Okay, so you need to stop whenever your n is equal to less than 0. Then if that is the case, you need to print your output. Okay, then in all other cases you need to keep on trying the brute force approach, like append. What you need to append, you need to append the last element. So after appending you need to generate a like substrate again. Okay, so n minus 1 and ls the output same. Now after completing that particular task, what you need to do, you need to pop out your topmost element. Okay, then you need to generate the subsets like n minus 1 s and output. Okay, so let's go and call this particular subset generate subset where n is equal to 2. Okay, and our input list is 1 comma 2 comma 3. Okay, now let's try to execute this. Okay, let's try to. Okay, so yeah, sorry, we need to return here. Okay, we need to return back here. Yeah, that's the issue. Yes, we got it. Since we are traversing from the end, like that's what we got it. If you wanted to put like from the 1 2 3, then you can say pop left, I guess. Yeah, pop left. Left means it will pop at this particular stage. Okay, you should write pop itself. You should write pop itself. uh, I hope you have understood. And if they ask you to return all these cases, then you should maintain a global thing. Okay, then put it all your output into the one output, like a result kind of thing. Then you can return that from your main function. Okay, so yeah, usually it works. Okay, if you are in an interview, if you tell this particular solution, like if it is not an product based company, they will accept that. If it is a product based company, then they will ask you to optimize this. So as we all know that there are some setbacks or drawbacks for the recursive solutions. So if I say what is the time complexity of this guys, you can figure out, okay, how many times we are calling, how many times we are generating an tree. Okay, so if I go to the tree, okay, I can just I can go to the tree and I can see. So at the end, okay, at the end, how many subtrees I have, like so how many leaves I have. So can I say I have almost 8 leaves, 8 leaves, 8 leaves, like so 1 2 3 4 5 6 7 8. So I'm generating that many answers. Okay, then how, what is the 8 in terms of this n? It is going to be 2 power 3, right? So where n 3 is equal to n, so I can say that the complexity of this particular algorithm which we have written is 2 power n. Okay, 2 power n. You can just imagine. Okay, so if I have given you 10 power 4, will it work or not? Okay, it's up to your imagination. Usually exponential time complexity solutions hai na, interviews are not interested in that. Okay, so they will ask you to optimize that. So how to optimize this, it's we'll discuss that later. Okay, using dynamic programming. Yeah, you can use dynamic programming here. And at the same time, this problem can be solved using loops as well. Loops as well. So just give it a try. Okay, just give it a try. Give it a try. Okay, first try. Then if not, or if yes or no. Okay, yes or no, go to online or read article. Okay, article. So yep, you can just simply Google search subsets or power set of a array or list. Okay, you will figure out, like you will find this question. Okay, you will be redirected to either GeeksforGeeks or lead code website for problem submission. Okay, where there you can have plenty of tutorials or discussion forum to discuss your solution, and you can read the other solutions as well, which is an optimized kind of stuff. Okay, yes, so that is your assignment for the day. And also try out, okay, there is an solution which uses bit manipulations. Okay, bit manipulations. Okay, try out this solution as well. Okay, try out this particular, go through this. Okay, I will discuss this tomorrow. Okay, bit manipulation solution. So I will discuss this bit manipulation solution tomorrow, in tomorrow's, yeah, tomorrow is Friday, right? Yes, I will discuss it tomorrow, no worries. Yep, so done with that note. Yes, so yeah, see you tomorrow. Okay, with another problem. Another, it's, yeah, it's an 1 hour session, so we have discussed 2 problems. So usually, yeah, it will take some time to explain recursive solutions or dynamic programming solutions. but yeah, it is an must and should topic for go further, because the applications of recursion है ना are very huge. Okay, like if you wanted to solve tree problems, like tree data structure problems, without recursion, without understanding recursion, it's impossible. Okay, it's impossible. Okay, without understanding recursion, solving a tree problems is an impossible. Okay, and for even dynamic programming, you need to learn recursion. Okay, and yeah, like in some graph algos as well, it is going to be a fundamental topic like data structures. Okay, so yeah, it's non skippable topic as well. Okay, so cool. Okay, tomorrow we'll discuss another amazing problems. Okay, so we'll try to discuss this like a bit manipulation problem and some other problem. Okay, so yep, sure, we'll see you tomorrow. Okay, bye bye.